Introduction to Time Series Statistics, Trend and Seasonality. Welcome to the lesson. Today, we are exploring how to analyze time series data, focusing on trends and seasonality. Time series is data collected over time, like monthly temperatures or the number of airline passengers each month. You will learn how to plot, decompose, and understand these patterns in Python. Running the cell now. What are trend and seasonality? Trend is a general direction that data is moving over a long period. Seasonality is a pattern that repeats at regular intervals, like higher ice cream sales every summer. Let us see these in action. Running the cell now. Let us load the airline passengers dataset. This data tells us how many people flew each month for over 10 years. We will check the number of rows and columns, and look at the first few records. This is the setup for our data. We are turning off unnecessary warnings. We are using pandas to work with the data, and matplotlib to make charts. Here, we load our sample time series, which is the number of airline passengers over time. We set the URL, so pandas can read the CSV directly from the internet. We load the data file into df, which stands for data frame. Next, we print out how many rows and columns there are in our dataset. Finally, df.head shows us the first 5 rows, so we can see how the data looks. Running the cell now. Practice, try loading a different time series from the list above. What does your .head show? Next, let us visualize the monthly passenger counts with a line chart. We are creating a line chart to display how many passengers there are each month. We make the plot wide enough to see the details. We plot months on the x-axis and the number of passengers on the y-axis. A chart title makes our graphic easier to understand. We label the horizontal axis as month. We label the vertical axis as number of passengers. We rotate the month labels so they do not overlap. This makes sure the layout looks neat. Our chart pops up, showing the pattern in the data. Running the cell now. What do you notice in the plot? There is a visible upward trend and regular repeating bumps, which suggests seasonality. Let us learn how to separate these patterns. Running the cell now. It is easier to work with time series when the date column is the index. Let us set the month column as the index and convert it to date-time format. We are changing our month values to actual date so Python recognizes the time steps. Now, the data frame uses month as its index, so everything lines up by date. Running the cell now. We can break down our series into 3 parts: the overall trend, the repeating pattern or seasonality, and what is left over. Let us use stats models to do this automatically. Here is a plot showing each part. We are using a tool called seasonal_decompose from stats models. This separates our series into trend, seasonality, and random noise, called residuals. We call the decomposition, telling it to expect 1 full cycle each year, or 12 months. The trend part shows the general direction over time. The seasonal part shows repeated cycles, like holidays or summer peaks. The residual part is what remains after we remove trend and seasonality. This line creates plots for all 3 pieces and the original data. The title explains the chart shows how the series was split. We tell Python to show the chart now. Running the cell now. Try changing the multiplicative model to additive. See how the components change. Sometimes we want to see the main patterns on one chart. We are drawing just the trend and the seasonality, so we can compare them. The chart is wide and easy to read. We plot how the long-term trend moves over time. We also plot the seasonality, scaled near the same range to see its effect. Adding a legend makes it clear which is which. The chart title describes what we are seeing. We label the horizontal axis with month. We display the chart. Running the cell now. Trend: is the series rising? Notice if the trend line goes up, down, or stays flat. This tells us if passengers are increasing or decreasing over the years. Running the cell now. Seasonality: when do peaks happen? Can you spot repeating patterns that happen every year? Seasonality could be due to holidays, weather, or business cycles. Running the cell now. A moving average smooths out noise and helps us see the trend clearly. Let us add a rolling mean to our chart. We are making a new column with a 12-month rolling mean. This shows the average number of passengers for each year period. We plot the original numbers and the moving average together. Both lines help us compare month-to-month changes with the long-term trend. The moving average use is red, making it stand out. The chart title explains what is happening. Month goes on the x-axis. Passenger counts are on the y-axis. A legend tells us which line is which. The chart is displayed. Running the cell now. Rolling standard deviation shows how much the data varies from the average each year. High variation can signal that there are big jumps or drops in certain months. We calculate how much passenger count changes from the average in each 12-month window. This helps us spot times with lots of ups and downs. We plot this rolling standard deviation so we can see where the volatility is highest. The purple line stands out for this part. The title explains what the chart shows. Months go along the x-axis. Standard deviation, which means typical distance from the average, is on the y-axis. The legend labels this line. The chart pops up for us to study. Running the cell now. Let us check which months typically have the most passengers. This bar chart summarizes the seasonality. We group our data by month and take the average for each one. This way, we see the typical passenger count for every calendar month. We make a bar chart to compare averages across all months. There is a bar for each month from January to December. The x-axis names each month. The title describes the chart. Every bar shows average passengers for that month. The chart displays the seasonality pattern. Running the cell now. To forecast, we split our data into training and test sets. The last 12 months are kept aside for testing. We find our split point by leaving out the last 12 months as test data. The training set holds the past values. The test set holds future data we want to predict. We plot both on a single chart to see where the split happens. The purple line is for training data. The red line shows the held-out test period. The title explains what this chart shows. The x-axis is calendar months. The y-axis is number of passengers. A legend makes it clear which line is which. We display the split. Running the cell now. A simple way to forecast is to just repeat the last known value. Let us see how a naive forecast compares to the real numbers. We grab the last month's true count from our training set. We fill every test month with this value as our prediction. We make a new plot showing the original training set, the real test data, and our simple forecast. The forecast is drawn with a dashed green line. The title labels the chart. Months go on the x-axis. Passenger count is on the y-axis. A legend labels each part. We view the result. Running the cell now. We need a way to know how good our forecast is. Mean absolute error is a common way to measure prediction mistakes. Let us calculate it. We import a metric from scikit-learn that measures average error size. This line calculates the mean absolute difference between real and predicted values. We print the result so we can see how well our naive forecast performed. Running the cell now. Let us take each test month's value and subtract last year's value to see if seasonality is stable. We create a new column to record the difference between this year's and last year's same month passenger numbers. This difference shows whether things are steady or changing. We plot these differences as stems, so spikes show big changes. Month goes on the x-axis. The y-axis shows the gap compared with last year's values. We show the plot to detect shifts in the pattern. Running the cell now. Mini Project Part 1. Simulate your own trend and seasonality. You can create your own fake time series with a trend and a seasonal pattern using NumPy. Running the cell now. Let us create a time series that has an upward trend and a repeating seasonal pattern. Even some randomness is included. Here, we plot our simulated data. We import NumPy for making our own numbers. The random seed ensures everyone gets the same data each time. We build a list of months for 3 years. We create a steady trend from 50 to 150. This seasonal effect uses a sine wave, which goes up and down each year. Noise adds some random ups and downs, like real life. We add trend, seasonality, and noise together to make a synthetic time series. We plot it all, using markers for points. The chart title describes this as simulated data. We label both axes for clarity. The new plot appears. Running the cell now. Mini Project Part 2. Analyze real-world trend and seasonality. Pick another dataset, like daily minimum temperatures, and repeat the analysis steps from above. Compare what you discover. Running the cell now. Practice, try your steps with the minimum temperatures or sunspots data. Can you spot seasonality and trend? Share your results in the comments below. Let us practice reading and plotting seasonality for one more dataset. Type the for airline or the D for daily temperatures when prompted. We will draw a bar plot of averages by month, or plot all airline passengers. We import Seaborn to help us draw better-looking plots. We ask which dataset you want to use, airline or daily temperatures. If daily temperatures are chosen, we load them from a CSV file. We turn the dates into proper date-time objects. Now, we use the date as the index, so Pandas knows these are timed steps. We extract the month number from each date. We compute the average temperature for each month. We make a small bar chart by month, showing average minimum temperatures. We color the bars to make it pretty. The chart title says what is shown. The x-axis is labeled month. The y-axis is labeled minute temp in Celsius. The chart is displayed. Otherwise, if you chose airline data, we plot all passengers over time again. We set the figure size for clarity. We plot number of passengers by date. The title labels the chart. Months go on the x-axis. Number of passengers is on the y-axis. We show the chart. Running the cell now. Now, try analyzing the pattern. Which months or periods stand out to you? Best practices for time series analysis. Always plot your data first. Use rolling statistics to spot trends and changing variability. Remove missing data or explain it. Always check for outliers or data entry errors before forecasting. Overfitting can happen if we try to match every single up and down. Focus on learning from patterns, not just predicting the numbers. Running the cell now. Extra tips. Use .resample, m-ig in Pandas to change frequency, like from daily to monthly. For quick decomposition, stats models and profit are great for beginners. Try plotting autocorrelation with pandas.plotting.autocorrelation_plot. Running the cell now. Challenge. Try to build a forecasting model using these steps on another dataset, like daily COVID-19 cases or sunspot numbers. Can you spot both trends and seasonality? What surprises you? Running the cell now. Remember to like and subscribe for more tutorials. Recap. Today, you saw how to load and visualize time series data, break it into trend and seasonality, smooth with rolling statistics, and make simple forecasts. These skills are the first steps toward more advanced time series analysis and forecasting. Great job learning today. Running the cell now. Want more? Subscribe to the channel and check out the probability and statistics playlist for more hands-on demos and challenges. Comment below with your favorite time series example. Running the cell now.